Hi, this is the Tinker and Create class on digital game design. My name is Doug Tepe, and we are in class 5 now. This is the class where we're going to be going over how to add our game over message and any other message we want to add. And I'll see if we can add some more obstacles and make the game a little bit more tricky and perhaps a little more fun to play. So, let's see if we can get started here. One thing I wanted to mention too was that since we're using Unreal Engine, you have to make sure that when you go to open it, you go to the Unreal Projects folder and you double click on it one time. I mentioned this in previous classes, but if you keep on clicking on it because you're impatient, you might end up loading too many versions of Unreal at one time, which can cause all sorts of problems and maybe even crash your computer. Alternatively, of course, the safer way often to open up Unreal Engine is just to go straight into the Epic's game launcher and click on the Unreal version that you are using, and then from the menu there, go ahead and load your project. So, going ahead and taking a look at our project here, just to go over a little bit of what we covered last week. We had some fun sticking in some sound effects right towards the very end, as well as some particle effects down at the bottom here. And when we play, I don't know if this would actually get caught by the live, but you should be able to hear the crackling sound of the fire here. So on the right side here, I have the fire particle effect. On the left side here, I have a blueprint, which is combining both the sound effect and the particle effects of fire at the same time. The other thing we covered last week was our game over event. If you step onto the lava, it restarts the game in 2 seconds. Now, of course, one of the things you might notice here is that I'm still able to walk around during that 2-second period, so we're going to see if we can fix that today to block the player from controlling it at that point. And we'll also include a game over message, so you know full well that you landed on the lava here, and that the game is over, and it's going to start you over again at the beginning. The other thing we covered last week, too, was our launch pad. So I'm going to see if we can add a few more obstacles here, because right now this corridor here is awfully easy. We come to the end of this corridor, nothing really happens until I get to the launch pad. But it is pretty cool how I can step onto the launch pad and bounce off of it. So let's see if we can get going here today. First things first is that I'm going to show us here how we can... Oh, excellent. I got a report that you can't hear the fire and smoke. Awesome. So anyways, taking a look at blueprints here. Now, there's the blueprints that we created last week. One was the launch pad, and the other was the game over event. So those 2 blueprints I placed right here into my main content folder. Now, as you can imagine, though, what's going to happen is that as I start creating more and more things, my main content folder here is going to start getting pretty cluttered. Now, Unreal is pretty handy. They give me some colors here to let me identify what it is that I'm looking at here. So, for example, my level maps are in this gold color. My materials are green, and blueprints are, of course, blue. But for organizational purposes, it's often helpful to actually use the file system that they've included here. This file system works in a similar way as how Windows works. So you can either drop down the Add New menu here, pressing the green button over on the left-hand side. And right up on the top of this menu, there is a New Folder option. So to keep yourself organized, you can create a folder called Blueprints. And likewise, too, you might even want to create one called Materials. And as we go along, we'll probably even want to include folders for our models and shapes, different artwork. In the starter content, you'll see that they even refer to a lot of their 3D models as props. Again, this is part of Unreal's thing where they try to make sure everything is being termed in the same way as the movie industry. So when we're dealing with different scenes and things like that. We can even call them props and the like. So they've got in their starter content here, they got props and shapes as well as their own blueprints. The blueprints that we were messing with over here, of course, was the blueprint effect fire. So once I have these new folders created, I can go back to my content folder, grab onto my game over blueprint and copy it into, or actually I'm going to want to move it into the blueprints folder. Same thing with my launchpad. I click and drag it over there. I select move here, and thus it'll make it easier for me to find this at a future date. Now, of course, with these blueprints here, these are my blueprints and I created them myself, but you can also crack open some of the other blueprints to see how Unreal had made, or how the Epic Games Company had made their blueprints. So we can take a look at the blueprint effect fire here by opening it in the content. Alternatively, you can always just take a look at your world outliner. So let's say I click on my blueprint effect fire here, and I look over on the right side in my world outliner here, and you're going to see that next to its name, where it says blueprint effect fire, it says type, and it actually gives me the option right here to edit the blueprint. Same thing down here. They give you many, many places to edit the blueprint. So right down in the details menu, there's also a big blue edit blueprint button. We click on that, we say open blueprint editor, and we will see the event graph for the fire, as well as the viewport for the fire. Here's the fire. So again, this blueprint is actually not doing anything terribly fancy. We look at the event graph and there's no actual programming going on using blueprints. There's nothing going on in the construction script. It's really just our viewport here. So we look over here on the components and we can see that all it is one component being the particle effect. They label it as P fire. And then another component saying fire audio. And that's it. The two are combined right on top of each other. You can even see the sphere here where the sound effect can still be heard. And then it eventually gets louder and louder until it gets to its maximum loudness where you're inside this inner sphere. And then as soon as you pass beyond that outer sphere, you can't actually hear the object anymore. So this is pretty cool. They actually will let you see how your components are working together in your blueprint. So combining two blueprints together is a very handy way to do all sorts of cool extra effects and the like. So we're going to do that here. Well, you know, I was actually saying that I was going to go off and do the game over first, but I'm already talking about combined blueprints. So let's actually go ahead and do one combined blueprint here. So to show how we can use combined components in our blueprints to do extra effects. So closing out of this, we're not looking at Unreals anymore. We are going to want to create a new blueprint here. This one's going to be a spinner. So the spinner will rotate around in certain places where you want to make it complicated for the player. Perhaps right here on my upper level. See, on the lower level, they have to be quick and clever to get to my launch pad. Of course, that's a very broad launch pad, plenty of room to get to it. But if you get to the upper level, then it's almost easier because once you're up there, then you can just run right across. Well, what if I actually had a wall here that could actually push you off if you weren't careful? So I'm going to create a spinning wall to put up on the top here. And that really is done just by creating a new blueprint that is a combination of two blueprints. So what I'm going to do is I'm going to go down here into my content browser, double click on my blueprints. I'm going to see my game over blueprint and my launchpad blueprint. I am going to add new. Click on the blueprint class here. It's going to ask you what kind of blueprint you want to make. As a reminder from last week, we are primarily only working with actors. So an actor is a kind of blueprint that will be acted upon somehow or another in our game world. It can be placed or spawned or controlled somehow, well, not controlled by the character, but moved by the character, say if they bump into it or something, and it can push the character or the like. As far as character-controlled blueprints are concerned, we're looking at things like the pawn and the character blueprints. Those are things where if you actually control with your game controller, whether it's the keyboard or the mouse or a game controller for a Nintendo or something like that, those would actually directly control the blueprint. But we're just doing an actor, the most simple kind of blueprint here. I'm going to click on that. It's going to ask us for a name. The name will be Spinner. Easy enough. Now let's double click on Spinner here. And in our Spinner blueprint, we're going to see here, again, this is a blank blueprint. All it has is the default scene root, which is marked just by a little dot right in the middle to let us know that this is the center of our blueprint here. We're going to go up to the Add Component button in the upper corner here, drop that down. And we can either do a search for, or just look about halfway down here, is the static mesh. Make sure you don't accidentally click the skeletal mesh. We're doing a static mesh here. This static mesh we will call our wall, I guess. Perfectly good. Now, as I mentioned last week, when we create the static mesh, it hasn't actually figured out which mesh we're going to use. So we look over on our details menu over here on the right side. About halfway down, we see there is a static mesh option. We can drop down this menu and do a search for a wall. These are the walls that are all included in the starter content pack. And the one that I usually like to use is 400 by 200, so 4 meters wide by 2 meters tall. 2 meters is about the size of our character, I believe. Well, that's good enough. We'll add that in. Now it seems really huge, just because we're actually kind of zoomed in on it. So I'll back this out a little bit by just rolling my mouse wheel backwards. Now I can see the whole thing. So you see right now it is hinged off of the center of our scene root here. And this is actually perfect because once it starts rotating, I want it to actually rotate around that center point there. So just as I mentioned, when we're creating these sorts of combined component blueprints here, we only have to actually add one more component here to get this rotating. And Unreal was very handy. The Epic Games Company was very handy. They gave us a component that has a very simple name called Rotating Movement. So you can do a search up here by typing ROT, or again, just scroll down here. Eventually you'll get to the section that is called Movement here, and you'll see a bunch of different kind of movements that we can do. Rotating movement is the one that we want. Press Enter because its name is perfectly fine. So now what it's going to do is that it's going to rotate our entire blueprint here. Now, of course, our entire blueprint here is just the wall static mesh that we added. So that's great. Looking over here at the Details menu on the right side, it says that the rotating component has two different variables that take X, Y, and Z vectors. So these X, Y, and Z vectors basically just say how much it's rotating, its rotation rate. In this case, it's 180 degrees per second. And then the pivot translation is referring to where it is rotating from. In this case, it's going to be rotating from 0, 0, 0, or the center of our scene root here, the dot. So 0, 0, and 0, that is a perfect place for me to rotate. It's going to rotate around the Z-axis. Whenever you rotate something around the Z-axis, this is what's called a yaw rotation, Y-A-W. So yaw rotation is the same kind of terminology that they use in aviation or even in nautical terms whenever you're referring to something that is rotating around its center. If something rotates up and down, let me get my face back on here. If something rotates up and down, then it's what we call the pitch. If something rotates from side to side, we call it roll. And if something rotates around the center, we call it yaw. So when we are talking about rotating around the center, we are saying it's going to rotate around the center 180 degrees per second. Its yaw is going to be 180 degrees per second. Let's see what it looks like. Right here in the middle, above our viewport, is this simulation button. When you click that, it will show you what your blueprint is going to look like when it's activated. So this is perfect. I can see now that my wall is rotating around in a clockwise direction at about 180 degrees per second. So, of course, now you can see the possibilities for changing around our numbers. We can make it go a lot faster. I can change it to 360 degrees per second. Now, when I simulate it, it goes even faster. I kind of like the slow motion of 180 degrees. We can make it more difficult later, but for now, that's good enough. So we're going to click Compile and Save. Again, this is just to check to make sure that our programming was correct. Since we're only including just 2 components here, there's very little chance that we could have screwed this up. So our compile is going to give us the check mark, no problem. Now we click the X button in the upper corner. And now we're back in our world here. We can click and drag our spinner somewhere into the world. I'm placing it right up here in the center of my upper platform here, because I don't want to make it too easy if you end up deciding to skip the launch pad. Now, as we run down here, we jump over the lava, climb up to the platform. Aha, I thought I took the easy route, but not so much. Here is my rotating spinner. And if I stay here too long, oh no! It's going to push me off. Game over. Now, one thing at least to note here is that if you are not moving, it's not actually going to bump into you. There is another setting that you can remove, that you can change, excuse me, so that way blocking objects are also pushed. But right now, it's assuming that if there is a blocking object there, it doesn't want to accidentally crash into it, so it will still pass through it. That is kind of handy, because let's say, for example, if I had a whole bunch of rocks and things up there, and I put the rock right in front of my spinner, I don't want it to actually break the spinner so that way the spinner never moves. But I still want it to push the character. Now, one last note before we go on to Game Over. It's just going back into the spinner again, and we click on our wall. You're going to notice down here in our details section that right below where it says our static mesh, there's also the materials, where it just says the material is the basic wall. This is what comes automatically with the wall, but you can change it to something else. Now, in the running style game that I've designed before, and that I was featuring in the first class, I actually switched this over. I think it was to the chair. No, it wasn't the chair. But you know what? The chair could be actually really cool anyways. There it is. This is actually the chair material. It looks kind of funny because it's meant to be wrapped around the chair object. And each one of these little shapes you see on here actually has a very specific place that it's supposed to go on the chair. But on the same token, it does actually create kind of a cool effect here. Well, I can't remember which one I did. You can, of course, go and find your own preferred material that you want to use. But just keep in mind that if you want to change material, you have to go back into your blueprint here and change it. And then it will affect every single time that you include this particular... There we go. I'm going to use the hex tile. That's very space age looking. So anyways, yeah, if you want to change this, you're going to have to go in and change it on every single one. Because you see that once we're actually here with the spinner in our game world, and I click on it, you look down here in my details down here, you're not going to see any way to actually change it here. Now, we can actually change that, and I will actually include that, so we can actually have it changeable in our details. But for now, every time I copy this particular blueprint, so let's say I press the Alt button, drag it off, and have it so that way I've got 2 spinners going right next to each other. This can make it even more tricky. You'll see that both of these spinners have the exact same material, and I can't necessarily change the material or anything. So we will cover that here a little later in the class. For the time being, I do want to make sure, though, that we get to how we can include the game over text on the screen. So let me just come up here to demonstrate the 2. Here we are. Here are my 2 Ah, it's knocking me off. My two spinners. Ooh, I just barely made it to the other side. Awesome. Okay, so there are my two spinners for now. Now, for adding on text onto our screen, we're going to have to make some changes to our third-person character. But before we make those changes to our third-person character, we need to create the actual widget. This is what Unreal calls it, a widget, which actually is going to be hung on our viewport, on the screen itself. So when Unreal creates these widgets, it is part of its Unreal Motion Graphics System, or UMG for short. So to create a new UMG, or a new widget, that's going to be hung on the screen, that's going to be having all of our text and things, we're going to create a new folder here, because we might end up using a bunch of these throughout our game design here. So I'm going to create a new folder and call it UMG for Unreal Motion Graphics. I'm going to double click to go in there. And now that I'm in here, I'm going to add a new. Now this time, this is not necessarily a basic asset, so we're not going to see any widgets listed here up on the top. Instead, we have to go down to the user interface menu down at the bottom. So a widget, of course, is a user interface. It's interfacing with the user. It's how we give information to the user on how to play the game, or just to announce to them that they've lost the game, for example. So down here at the bottom is the Widget Blueprint. So again, to find this, you go to Add New. Down all the way at the bottom of this menu is the user interface, and you're going to select Widget Blueprint. Click on that. We're going to give it a name. This name I'm going to call the HUD, or the Heads Up Display. For those of you who are familiar with first-person games and third-person games, a HUD is very common, just referring to any sort of information that is displayed on the screen. It's your heads-up display. It's what you can see at all times while you're playing the game. So I'm going to call this the heads-up display. It's going to have basically every single possible thing that I might need to display on the screen, including, of course, the game over message. Once you've created your HUD, you double-click on it, and it's going to take us to the Widget Editor here. The first thing we see in our Widget Editor here is the Designer view. So this is a little different from how the Blueprints Editor works, but it still has some similar concepts at least. Right now, at least in the Designer view, it means that we can actually place the words in this space right here. This open space here is called the Canvas panel. It refers to basically your entire screen. And then there is the Graph menu, which is similar to Blueprints at this point. The Graph menu is how we would actually interact our screen, our user interface, with the different blueprints. So for example, if a game over event occurred, then we're going to actually make sure that it can pick up that information through the event graph here. Going back to the Designer, the Designer is going to be kind of similar to what people might already be familiar with in terms of various publisher software or even doing web design and the like. Any sort of user interface software will use a lot of these similar concepts here. So to add some kind of text into our screen here, we just go over here to our palette on the left-hand side, and you'll see that there are a bunch of different things that we can use. Buttons, borders, checkboxes, images, progress bars, and of course down at the bottom is text. Now for adding our game over message, we're going to want to include text. So let's just grab the text by clicking on it and dragging it into our widget here. Dragging it into our canvas panel. And you will see over here in the hierarchy section, it now has it listed inside the canvas panel. So inside the canvas panel is our text block. And then our text block can contain some kind of message that we want to include. So this is similar to the world outliner in the main game editor. The hierarchy just lets you find all the different things that you have added to your user interface. So we placed in the text block here. Now the first thing you're going to notice is this little star thing that's appeared in the upper corner. This is the anchor. So what it's doing is that it's letting you know that this particular text box is anchored to the upper left-hand corner of the screen. Now, the reason why this might be important is that if you were designing a game for different devices, let's say if I want my game to be a mobile game, then I want to make sure where it's anchored at any specific time. Because not all screens are going to be widescreen. What if you're playing it on a mobile device and it's going to be portrait size? So in other words, very narrow through the middle and tall. So of course you can see here in the screen size menu, there are all sorts of phones and tablets and things that you can actually simulate here, such as a 19-inch screen monitor for computer games, all sorts of laptop possibilities, even TV possibilities and the like. And of course, each time we do that, it might end up changing how we work with our canvas here. Now, I'm just designing my game to be run on a computer, on a desktop, or a laptop here. So it's fine. My screen here is going to be a widescreen style. And I'm just going to anchor it up into the upper corner. But you do have to be careful because as you shrink it and grow it, and as you can see by me grabbing onto the outside of my canvas panel here, they're handily giving me dimensions of a lot of common devices. So let's say, for its example, it is a cell phone. If I have it in a cell phone style here, and I have it anchored in the upper corner, let's say I have it off the side of the screen here, this means that my text isn't going to show up on the screen. It might show up, of course, if I was playing a widescreen on a computer or something, or on someone's television. But it's not going to show up if I'm playing it on a mobile device. So this is where the anchor comes in handy. Let me pull this back towards the size of my screen. Here we are. Here's my text block. So to change where the anchor is located, you drop down the menu here in the Details menu, and you can tell it to anchor from a different side, or you can even have it anchored in the center. So the center of whatever device it is that you're using. So now, of course, my star is in the middle here. My text block is based somewhere off of the center, and then I can put in my text. You'll see underneath here in the Details menu, there's position X and position Y. So I can change those to 0 and 0. That means it is going to be in the center at all times. The only problem here, though, is that now you notice that my text block is hanging off the bottom of the anchor. So I can even fix that too by changing its alignment down here to 0.5 and 0.5. Basically meaning halfway through the middle of the position of the anchor. So 0.5 and 0.5 now means that my text block is in the absolute center of whatever device I'm using. That's kind of handy because for a game over message, you kind of want to make it big and right in the middle, right? You want to laugh at the player because they had screwed up and now they have to start all over again. So, to change how our text appears, you just keep on going down through the detail menu here. Right now, our text is text block. So instead, we can change that to "You lose!" exclamation point with 2 exclamation points. There we go. And of course, it's spilling a little bit beyond my box here, so I might need to increase the size of my box, which then, of course, changes its location again. All right, so now it says "You lose." Actually, maybe my Y, I want to change it back to its original size again. This doesn't really matter so much anyways, actually. The text will still actually sit in the right place, even if it spills over the side. So then we can go down here to our font, open up this menu by clicking on the little triangle here, and you can change the font family to whatever else you had. Unfortunately, Unreal, even though they have given us a lot of free assets, free 3D models and other things, they have not given us any other free fonts. So if you want to use some other font, you're going to have to import the font. And of course, you might even have to get permission to use a font, because a lot of fonts don't necessarily come for free for use in video games. They might just come with your computer. So you'll have to import a font and then use it there. But Roboto, which is what comes automatically with Unreal, is perfectly fine to use. Right now it says it's bold, and right now it says its size is 24. We can change this to 120. There we go. Now it's really huge. Okay, so here we are. Now I can change its justification to be centered. So now it appears right in the middle, hanging off of my box. That's fine that it's spilling out of the box for now, at least. It's only just doing a very limited thing, at least. So, last thing is we will... Well, for now, at least, I guess we'll leave this here for now, at least. This is at least going to be our message. It's going to appear on the screen. So now I'm going to show you how to get it to appear on the screen. Same thing as with blueprints. We need to compile it and save it. And before I go on, I just wanted to say hello to those of you who have just joined us. This is the Tinkering Create class on digital game design. This is our 5th class here, week 5. And today we are going over how to add game over events and game over messages to our game over event. So this is the halfway point through our class. Again, this is Tinkering Create class on digital game design. My name is Doug Tepe. And here we go. We're going to continue on with adding words to our screen. So once we are done with this, we click the X in the upper corner to close this. And here is our HUD located in the UMG. Now, what we need to do is we need to attach this to our third-person character. Since the third-person character is going to be controlled by the main player, that's usually the best place to go to actually set whatever messages we want to do. Now, of course, if we were doing a multiplayer game, this could get more complicated. Don't worry, we're not going to get this more complicated. We're just sticking only to the third-person character by itself. But obviously, of course, if you had other players, you don't want to have the game over message appear for other players. So you'd actually have to set up different blueprints to control when these messages appear. So to edit our third-person character, you go to the folder called Third Person here. Excuse me, not Third Person BP. So this is referring to the third-person blueprint or the character blueprint that they have already provided for us. Then we click on the third-person character that's there. Now at this point, we are, for the first time now, taking a look at how the third-person character works. Inside the third-person character, we can take a look at the viewport here, and we will see the Unreal robot and the camera that's attached to it. You can even see over here in our Components menu, there is the camera boom, which is represented by this red arrow attached to the camera, and then the follow camera that goes along with them. And then lastly is this character movement. You might recall, of course, with our spinner, there was the rotating movement. So for characters, they actually have their own special character component called character movement, which includes all of the extra details that we were messing around with in week 2. Things like jump height, speed, and other things. So to go off and make changes to this then, we can go over to our event graph, and you will see that there are a lot of these red nodes here that are all representative of different events. So just like with our game over event where we had a on begin overlap, or with our launchpad event where we had on hit component, in this case, all of these are going to be representing the different controller functions. So it says input axis turn rate. So turn rate is for controllers. So as you push one of the buttons on the controller, it's going to turn at a certain speed. Same thing with look up rate. Now, since I'm playing my game just strictly on the PC, this particular function is never actually used because I'm using a mouse. But as you can see right underneath here, there is the mouse input, which is input axis turn and input axis look up. So input axis look up is referring to whenever I'm pushing the mouse up and down. And it changes how the pitch occurs. Remember we mentioned earlier how pitch is referring to something that wobbles up and down, forward and backwards. Same thing with turn here. When I turn the mouse or I push the mouse left and right, it changes the yaw input. So to give you an idea, of course, what we're talking about is once I'm actually here in the game and I move my mouse left and right, I'm spinning the camera around the yaw. Or if I push the mouse up and down, it's spinning the camera along the pitch. So going back into our third-person character, you'll also see that there is the input action jump, which in my case happens to be the space bar. And when you press it, it jumps. Pretty easy, huh? Again, this is all stuff that is built into the third-person character, so there is already a function called jump. There's a function called stop jumping. So for example, if I set it up so that way when you jump, you can actually jump higher by holding down the space bar, then I'll continue to jump until I let go of the space bar, and then it'll stop jumping. Okay, so enough of this. To add our text to the screen, we need to add a new event node right at the top up here. The event node that we're going to create is called Begin Play. Now, those of you who might remember from previous weeks when I was creating new blueprints, event Begin Play comes in automatically for brand new blueprints, particularly if they are actors. In the case of the third-person character, they actually removed it here, but I want to bring it back in. The reason is that once the gameplay starts, I want to hang my HUD onto the screen. I want the HUD to be there at all times, the heads-up display. So at the Begin Play, I then want to draw off a chord here, or a string, let go, and what I want to do is to create a widget. So just type in create, and hopefully after typing in create, you'll see a whole bunch of different create options, but the one we want is under user interface here, create widget. We remember that our Unreal Motion graphics refer to all of the different components as widgets. And to set which particular widget we want to use, we drop down the menu here to select a class. So the choices are none, a sample, which just came along with the third-person template, and here it is, our HUD. We click on that. So now we have created our HUD. We then go to the return value here, because even though the HUD's been created, it's still not actually hung on the screen. All it does is that it just exists inside this return value here. So we're going to draw a string off of return value, and we're going to type in add to, and you'll see right here is add to viewport. So we're going to add to viewport. And now we'll see that it's automatically added a white chord along the top here. This is the execution chord. So what it's doing here is that at the beginning of play, it creates a widget and then it adds it to the viewport. All right, let's see if this is going to compile correctly. Gives me the checkbox. That's cool. I was expecting it to throw me an error, but perhaps not right now. I'll just say save for now and see what happens. Let's click on save, click on the X in the upper corner, press play. Oh yeah, there it is. All right, I thought I was going to have to declare which character it actually belonged to. I suppose not, but that goes back to what I was saying about multiplayer games. You should still actually say which character it belongs to, because again, you don't necessarily want it appearing on all cases. So here we are, I've now got my you lose thing appearing on the screen at all times. Now, of course, as you can already guess, this isn't what we want to have happen. It should only appear when you actually touch the game over event. So we're going to have to make a few more changes here. Cool. So going back into our third person character again. We're just going to pull one off the back here for the owning player, and we're going to say get player controller. I always forget how this works. I don't know if this is the right one that I'm putting. Oh, it gave me a checkbox. Okay. So again, the player controller is just referring to which particular player is controlling it at any given time. And it's going to say player index, referring to which player we're talking about. So the very first player is represented by 0, the second player is represented by 1, and so on. So of course, again, this is fine. We're only playing a single player game. The player controller is 0. That's fine. That's just good practice. Okay, so now we have our widget, adding it to our viewport. File it and save. Play. And there's our message. You lose. Okay. So now here's the problem, of course, is that we want this to only appear when we actually have the game over event. So to do that, what we need to do is I'm going to need to go and take a look here at the game over event itself. Double click on game over event. So here in the game over event, you might recall that when we overlap the box, it checks to see if who it is that's overlapping the box is the third person character. If it is, it just gives a 2-second delay and then it reloads the level. Great. But one thing we're also going to notice here now is that we have as third person character happens to be this particular node right here. So it means that I can actually reach inside the third person character and make changes inside there. So this is actually kind of handy because it means that I can go in and change whether or not the HUD is being displayed at any given time or not. So to do that, of course, we do have to go back and make one more change to our third person character again. There is another way to get to the third person character. One way, of course, as I mentioned, was to go into third person BP and change it there. Alternatively, you can also go to the Blueprints menu right up on the top of the screen here. And down in Project Settings, you're going to see there is a blueprint called the Game Mode, the third person game mode. And then inside that are all of the different game modes that are associated with the overall game. We are going to be editing the pawn or edit third person character, and then we can click on this to edit the third person character, and voila, here we are again back in our third person character. So that's a little bit more of a complicated way to do it. I still generally prefer just to go in and change it right here. But if for some reason you were creating your own characters and you were not actually using the Unreal robot that came with Unreal Engine, then you would want to make sure that you actually update your third person game mode. And in the third person game mode is where it actually has all of the different game mode related blueprints, such as the third person character. Okay, so anyways, that's complicated enough. Let's just go back into the third person character. So with our HUD widget here, we added it to the viewport. So instead of adding it to the viewport, I'm going to press the delete key here. I want to take the return value here, and right off the top of my actions menu here, there is one that says promote to variable. So in other words, I want to be able to refer to this in the future by some special new name. It's going to be a variable, meaning it's just going to be a different way that I can refer to it. And this is important because in the game over, I want to go off and say, hey, do something with the widget. So I have to actually refer to the widget at some later point. So here is my new variable. By clicking on this, you'll see over in the details menu on the side, it's called new var 0 or new var 0. We're going to change its name to HUD. And you're going to see now that this variable is listed over here on the side, on the left-hand side, under my blueprint, the new variables. So now I have a variable called HUD here. This is referring to the widget. So I click Save. File, then I click X. All right, so now when I press play again, all right, no HUD is visible now. Cool. All right, so instead now I go back to my content, click on Blueprints, click on my Game Over event, and now with my third-person character, I want to add a new node here in between third-person character and delay. So I'm going to select both delay and open level, pull them out a little bit so I've got a little more room. And as third-person character, I'm going to draw off a string here. And I'm going to say get HUD. So in other words, I'm reaching inside the third-person character and looking for that new variable I created called the HUD. And with the HUD now, draw off another string here and type in add to viewport. This is the same as before, but now we're actually in the Game Over event. So once a Game Over event occurs, we want to add the message to the viewport, give it the delay, and then reload the level. All right, let's give that a try. Compile. No error messages. Excellent. And save. Click the X button, press play. All right, so we're running down the hallway. Step on, you lose! Oh no! And then I start over again. Game loads again. Very handy. You lose! And it keeps on disappearing every time. Now, of course, the only catch is with this particular method of doing it is that I'm having the entire HUD appear every single time and then disappear every single time. And if I wanted to start putting other information onto the HUD, I might have to start using a different method because I don't want to have the other messages disappear. Let's say, for example, if I have a timer in the corner every single time the game restarts itself. This is actually a little bit too much fun. Okay, so anyways, we touch this, but for now at least, this is good enough. We start over again, it gives us a message, and we go back. Now, a couple of the other things we could do is we could actually stop the motion at this point. But what I think I'm actually going to do instead, let's see here, how much time do we have? We've got about 12 minutes left. What I'm going to do instead is actually start talking about seeing how we can make this into an endless runner game. Because as I mentioned last week, as we're running along here, I can stop at any time and very carefully go through all the narrow spots here and very carefully go up. But that's too easy, right? Endless runner games, the character always runs. They run forever. They always run. So we're actually going to go in and we're going to edit our third-person blueprint again. Going back to our content folder, we're going to third-person BP, into our blueprints again, double-clicking on the third-person character. So here is our HUD widget getting created and setting it in a new position. To change how the movement works, we just go down here a little bit to the right and down. And we're going to see that there is now input axis move forward and input axis move right. So in the case of my keyboard here, that's referring to the W key, which means move forward, and the D key, which means move right. And then, of course, you might be asking yourself, well, what about the A and the S keys, right? The S key usually goes backwards, and the A key usually goes left. Well, that's where this axis value comes in. So when it's referring to the axis value, if I'm pressing W or moving forward, the axis value is 1. Which means it's telling the movement of the character to go forward. If I press the S key, meaning I want to go backwards, the axis value becomes -1. Same thing with right. If I press D, the axis value is 1, which means I'm turning right. If I press A, the axis value becomes -1, which means I turn left. The only other thing you're going to notice here then is that it's checking to see which way the camera is currently pointing towards, which is set through the control rotation right here. So it finds out what the camera is pointing towards. It checks to see what its yaw direction is. It finds out what that direction is and then says that's the direction that the character is running in. So again, to keep in mind how these third-person style games work is that as I run forward, forward is always going to be in the direction away from the camera. So if I press W here and I move the camera around, W now makes it go backwards. So that's all it's doing. It's checking to see which way the camera is pointing, and then that becomes the new forward every single time. Okay, so now that we know what all these pieces are that are going into our movement input, if we want to make this into an endless runner, all we need to do is disconnect our move forward here. I'm actually going to want to leave the move forward in case I want to actually edit this later. So instead of just flat out pressing the delete key and removing it from everything, instead I'm just going to press the Alt button and click on the node here. So when you press the Alt button, it disconnects the strings that are attaching it to the next node. It's a handy way for me to keep in the move forward here to remind myself later as a quick way that maybe I still want to move forward in the future using the mouse buttons. I mean, not the mouse button, sorry, the keyboard's button, W and S for forward and backwards. So instead now my movement input here is sitting all by its lonesome self. It has a scale value of 1, which just means move forward at all times. And to experiment with this, let's just compile and save it, and I go back to my game, I press play. And here, if I press the W and the S key, nothing's happening. Now the A and the D keys are still working fine, I can go left and right, but the W and the S keys no longer work. That's because I disconnected the input axis move forward. So we need some way to get the add movement input getting pushed all the time, but not actually having it as some sort of input from the player. We want it to actually be a constant thing. So along with our standard event begin play here, one of the other standard events that comes along with blueprints is the event tick. So we're going to right click here and type in TICK. You will see right here up on top is event tick. So the tick is actually commonly used by all major game engines. So even Unity will use it and many others. It is referring to how many times per second a new frame is drawn on the screen. So of course you might have heard before games are often usually 30 frames per second or 60 frames per second. So it means that every single time it draws something, it's going to actually do the tick. This is very handy because, of course, in a game where it's dependent upon your actions, you want to make sure that every single time a frame is drawn, something is actually going to happen. This is also particularly handy because you don't want to necessarily tie events to seconds, because if your computer is not steady, and they usually are not steady, they're not always perfectly at 30 frames per second, you're going to have weird situations where an event might happen, but then it hasn't actually drawn it yet, and then you're going to see something suddenly jump across the screen that you weren't expecting to. So instead, you want it to be anchored to how many times the computer is able to draw a new frame, and so that's why we use the event tick. So it's going to happen 30 times a second on my computer, or 60 times a second on really advanced computers. So with the event tick now, we just go off, pull off a string off of our execution node and plug it right into the add movement. Underneath here is the delta seconds, which just basically refers to how many times per second the event tick is occurring. Well, so it's going to be a very small number. It's just a tiny fraction of a second. We don't plug this into the scale value because, again, the scale value we want to be 1, right? It is just going forward only. So instead, we're just going to leave delta seconds alone and make sure that the scale value is 1. The world direction is still being controlled by the mouse. That's good enough for now, at least. Let's just see how our event tick works. So we click on compile, click save, press the X button, and now we press play. And now the character is running at all times. And even once it starts over again, I'm still running, so I have no choice but to be very careful and choose my paths carefully because I've only got one chance to do it and he's still running on. I can't press the W or the S keys because they don't work anymore. Boing. There we go. Now, of course, one problem is that the mouse is still working here, so I can still have him go backwards, the Unreal Robot here go backwards. Oops, I barely touched it there. So, of course, for Endless Style Runner, oh, it's throwing an error message because I kept on adding the widget to the screen every single time. That's an easy thing to forget at least, but you know what? It's not the biggest deal. The game still plays fine. We'll work on fixing that later. Okay, so anyways, right now the mouse is currently controlling how it moves, so I can also fix that as well by just pressing the Alt button, clicking on this yellow value here, and it removes the yellow value from the world direction. So now the world direction is 0, 0, and 0. And this actually is going to create a slight problem. If it's just 0, 0, and 0, it means that we're not actually heading in any particular direction. So once I press play, he's not moving anymore. Right? So I still actually have to specify a specific world direction. So this yellow cord that gets plugged in here is what's called a vector. So it's not necessarily going to be a very high number. We're not positioning something in X, Y, and Z space here. We're just pointing. So if I'm just pointing along the X direction or pointing along the Y direction, all I have to do is actually just put in any number that is greater than 0. So 1, of course, is what's traditionally used. So I could say that the world direction is Z1. That might actually have some weird effects, actually. I don't want them to be floating up in the air. So actually, let's just make Z0. Sorry, I want to make it X is 1. So again, X is going to be heading down my corridor. You might even remember back when we were creating the corridor in the first place, when I painted the brush, I made it 5,000, or was it 10,000? 10,000 centimeters along the X direction. So of course we want our character to travel along the X direction. So our X is 1 here. I'm going to click compile and save. Click the X, now we press play, and now he's running along the X-axis. You will also see that although my mouse is able to still rotate the camera, it no longer controls where he's actually headed at any time. So now the only way to control whether I'm going left or right is with the A and the D keys. Holy cow, and here we are practically running out of time again. Now, of course, there are a lot of bugs on this. I'll go over them next week, how we can fix some of those bugs so that way our HUD properly appears and that we actually come to a stop here. Now, in my game that I was demonstrating, when we actually touch the lava, it actually hides the skeletal mesh of the skeleton and replaces it with an explosion. I'm going to see if we can actually do that next time. We're going to get it so that way once we touch the lava, the game over message appears. It no longer moves. An explosion will occur, which of course, mind you, the explosion actually comes automatically in our starter content. Again, looking down here in our blueprints, you'll actually see one here called explosion. And if we double click on the explosion and go right in here, you'll see in the viewport it appears. You can even click simulation and see it. I guess when I click simulation, you don't hear it though, but it usually is a very loud bang. Pretty cool stuff. So yes, we can replace the Unreal Robot, the mesh of the Unreal Robot, with an explosion, cause the game to come to a complete stop. We'll see if we can fix some of those errors, and we'll add in some more obstacles and the like. So that will be what we cover next week. I hope you guys had fun today. My name again is Doug Tepe. I'm with Tinker and Create, and this is the class on digital game design that we've been offering as a way to learn a little bit more fun STEM skills while we are learning Unreal Engine during the coronavirus crisis. So I hope you've all had fun. One thing I also wanted to mention, of course, if you guys have any particular questions, feel free at any time to ask them in the comments. I'm going to see if I can answer them next week. And if there's anything you'd like to cover, we'll see if we can also cover them in the class. Obviously, I can't do too many really complicated things. A very common request I get is to see if I can have the is to see if I can have the Unreal Robot do things like other animations and the like. And unfortunately, the Unreal Robot, though is free, unfortunately only comes just with the running animation, the jumping animation, and the walking animation. And there really aren't any other animations that can come along with it. Now, of course, if you have a professional animator working with you, you can then do all sorts of cool other animations like dancing and things like that. The game Fortnite, of course, is very famous for adding in all sorts of dancing animations and things like that. And we'll see if I can actually explain a little bit on how to import other styles and designs in week 7, so that way you can import other people's artwork and animations and music and whatever have you. So that will be what we cover in week 7. That will be the week after next. But anyways, next week we will be covering how to add more obstacles and the like. We're going to try and make it so that way our game over event is a little more slick and controlled. And so again, my name is Doug Tepe. I hope you guys had fun tonight, and I will see you guys next week at 6 p.m. next Thursday.